Hey, so in this video, we are going to be working on Unit 7 study guide, getting ready for the next math test. Now, in this unit, there was a whole lot of review. We have reviewed line plots, we have reviewed multiplication and division word problems, as long as multiplying mixed numbers and fractions, and then adding and subtracting fractions and mixed numbers within word problems. So you're going to see a lot of things that we've already gone over, but we're going to be applying them in word problems. So the first page of your study guide is going to go by really quickly and through this video. If I want you to have the study guide in front of you, and if you need to pause the video, work it out, and then you can play the video again to compare what you did to what I did. So this first one says you have 6 cans of string beans in the cupboard. Each can weighs 4/6 of a pound. How much do the cans weigh together? The first thing I'm going to do is I'm going to write an equation, but in order to write an equation, I need to understand that I have 6 cans or 6 groups of 4/6 of a pound. So since I have multiple 4/6 pound cans, I'm going to do 6 times the 4/6. Now, when we do this, don't forget your variable. Let's use C for cans. So I'm going to do 6 times 4, and I'm going to keep my denominator the same. So 6 times 4 is 24. And then I'm going to keep my denominator as 6. So that is 24, 6. Now, we have what we call an improper fraction. There are 3 different strategies we have done in order to convert a improper fraction into a mixed number or a whole number. So we can either draw a model, we can decompose it, or we can use division. So for this one, I'm going to use division. So 24 divided by 6. Think about your multiplication facts. 24 divided by 6 is equal to 4. So my answer is 4 wholes or 4 pounds. So 24/6 is equal to 4. Now, if you wanted to draw it out, I would just draw out my 6/6 shaded in. I need another 6/6. That is now 12/6. I'm going to do another group of 6/6 shaded in. That is 18/6. And then I'm going to do one more and shaded in. And I now have 24/6. All right, now this next one says Miss Marshall's cake recipe calls for 1 1/3 cups of milk. That's a mixed number. She wants to quadruple her recipe, so how many cups of milk will she need? Now, in this equation, I don't have any other numbers other than 1 whole and 1/3, but if you notice, it says to quadruple the recipe. Remember, quad means 4. So when you quadruple something, you are multiplying it by 4. So I'm going to do 4 times 1 1/3, okay? I've got a whole number times a mixed number. Now, when we multiply, there's a couple different ways, and I'm sure you have practiced it. You can either draw it out, or I'm going to decompose and then multiply. Let's try the decomposition. I'm going to break apart 1 1/3 into 1 1/3. Now I can multiply 4 times 1 and 4 times 1/3 and then put my answer or combine my answers together. So 4 times 1 is 4. 4 times 1/3 is 4/3 because you want to keep the denominator the same. Now this 4/3 is an improper fraction. Now we can't put 4 and 4/3 together without converting because then we have something called a double negative. So 4/3, if I wanted to convert it to a mixed number, that would be 3/3 is a whole, and I would have 1/3 left over, okay? So that would be 1 whole and 1/3. Now we're going to do 4 plus 1 1/3, which is equal to 4 plus 1 is 5, and add your 1/3 with it. So that is our answer, okay? 5 and 1/3. All right, now these next few problems we're going to go through fairly quickly, okay? Because this is just stuff, this is just review. The next 4 multiples of 1/5, they've already listed 1/5 and 2/5. Now we're just going to continue the pattern. Next would be 3/5, then 4/5, 5/5, which is equal to 1 whole. And then the next one would be 6/5, which would be 1 whole and 1/5. All right, B says 7/8 is a multiple of what unit fraction? Guys, a unit fraction is a fraction that has a 1 as the numerator. It's a unit or one piece of that fraction or of that whole. So 7/8, the unit fraction is 1/8. And then part C, we have the answer or the improper fraction, which is 5/3, and that is equal to 5 times a fraction. So 5 times what would give us 5/3? I'm going to keep my denominator the same. 5 times 1 is 5, so it should be 5 times my unit fraction is 1/3, would give us 5/3. Okay. Now, let's go ahead and move on. We're going to look at this next part here. Um, and for this next part, we are going to convert. Now, for this, I am going to draw a picture. And guys, on your test, you need to make sure you are drawing something to kind of help you keep track of your conversions. So if you don't know this, let me tell you the story of the Kingdom of Gallon. All right. So I'm going to draw a big G, and this is going to represent the Kingdom of Gallon. Okay. Big G. So in the Kingdom of Gallon, it is ruled by four lovely queens. Each queen who rules the Kingdom of Gallon has a prince and a princess. So each queen has a prince and a princess. Now, each prince and princess owns two crowns. They have one to wear and one as a backup. So we're going to give each prince and princess their own set of crowns. Okay, so two crowns per prince and princess. All right. Now, this is our Kingdom of Gallon, and these letters are going to represent quarts, pints, and cups. Okay. So your queens are your quarts, your P's are your princesses or your pints, and then your C's are your cups. Your crowns are your cups. So this story just helps me remember my conversions, and then your gallon would be the whole. Now, what's not on here are fluid ounces. Guys, you need to have fluid ounces memorized, okay? Because the fluid ounces are different than ounces to pounds, because fluid ounces, there are 8 fluid ounces that make up 1 cup, and that's different in weight, and you'll see what I'm talking about, okay? So fluid ounces. Let me rewrite that. So fluid ounces, and you will see it, excuse my spelling, you'll see it represented. It'll have FL and then OZ for ounces. Okay, so that's fluid ounces. Now that we have the Kingdom of Gallon, we should have this drawn on our paper. If you need to pause it to write it down, you can. We're going to use this to help us convert these. So in this problem, we have gallons, 1 gallon, 1 gallon, 1 gallon. How many quarts are in a gallon? Look back at the Kingdom of Gallon. We should have 4 queens, makes up 1 gallon. Now, in a gallon, since we have 2 pints per every quart, that would give us 2, 4, 6, 8 in 1 gallon, 8 pints. And then how many cups is that in a gallon? So look at your gallon. Cups or C's, that's 4, 8, 12, 16. So that's 16 cups in 1 gallon. Now we're going to convert a little bit more. It says 2 gallons is how many quarts? Well, since I know 4 quarts in a gallon, I'm going to do 4 times 2. That's 8 quarts. Now this says 6 quarts are how many pints? Well, since there are 2 pints for every quart, I can do 6 times 2. That's converting. That's going to give me 12 pints. And the last one, 9 pints for how many cups? Well, if we look back at the Kingdom of Gallon, I see that there are 2 pints for, I mean, 2 cups for every pint, but there are 4 pints, or I'm sorry, 4 cups for every quart. So 4 cups per quart. So since there are 2 cups for every pint, I'm going to do 9 times 2, which is going to give me 18 cups, okay? Now let's look at number 4. Number 4, we have another word problem, but we're going to work it out, okay? This is also converting, so we're going to use our Kingdom of Gallon to help us out. It says that Tanya's recipe calls for 8 pints of fresh milk. She had 5 quarts of milk and gave 2 pints away. Does she have enough milk for her recipe? You have to pay attention to the quarts and the pints, okay? Because we're going to be going back and forth here, okay? So the recipe she has, she needs 8 pints, but she had 5 quarts. Well, now let's see if we can figure out how many pints are in 5 quarts. So there are two pints for every quart. So she had 5 quarts. 5 quarts is equal to 10 pints. But then it says she gave 2 pints away. So she had 5 quarts, which is the same thing as 10 pints. She gave 2 pints away. That would leave her with 8 pints. So does she have enough for her recipe? Yes, she has exactly enough pints of milk for her recipe. Then it says how many pints of milk does she have? She has exactly enough, which is just 8. Okay. All right, let's keep going. All right, number 5, we have another word problem, but now we're dealing with money. We've actually done this recently. So it says Jordan wants to make sandwiches for his class tomorrow. He's gonna buy some bread, but each loaf of bread costs 75 cents. But look at what it says. They're having a sale, and you'll notice that a lot of grocery stores they have if they in order to sell more things, they have these sales where if you buy more than one or you buy an item in bulk, they'll actually lower the price of that item. So here it says if he buys 6 or more loaves of bread, then they will only cost 54 cents. Jordan needs to buy 8 loaves of bread in order to feed the class. So how much money will he spend? Okay. Well, since he needs 8 loaves and that the sale is 6 or more, so we're going to use the sale price for his bread, which is 54 cents. So there's a couple different ways we can do this. Okay, one way, if you don't want to multiply, you can do repeated addition where we would do our 54 cents plus 54 cents plus 54 cents. So we would do that 8 different times. But you know what? That takes a lot of time and effort. So here's what I'm going to do. I'm going to use multiplication. I'm going to multiply 8 times 54. Okay. All right. So I'm going to multiply 8 times 4 equals 32. 8 times 5 equals, or 8 times 50 equals 400 because 8 times 5 is 40. Add it together. That's 432. Don't forget to put your decimal because we're doing money. That would make $4.32. Okay. So Jordan needs to is gonna spend $4.32 on a loaf of bread. Okay. So that's $4.32. And they already have the dollar sign right here for us. Okay. All right, let's keep going. Wow, we are working with money again. Now, this word problem you need to pay very close attention to because we have a lot going on. So what we're going to do, we're going to split this in half because we've got 2 different scenarios to look at. All right, so the first part of this problem says we have 2 boys. They are Derek and Paul, or Paulo. So Derek and Paulo are cashiers and they both work at 2 different stores. So we're going to start with the first store. At Food Lion, they each work 7 hours a week, and together they make $210 each week at Food Lion. So 7 hours a week, $210, and there's 2 of them because it's Derek and Paulo. That's the first part of this problem. Then it says at Piggly Wiggly, we got another store. They each work 6 hours a week and they earn $204 each week. And that's at Piggly Wiggly. So we got Food Lion and Piggly Wiggly so which store pays more per hour, right? That's why they give us the hours per boy for each boy. That's why they let us know we have Derek and Paulo. That's 2 of them. And how much per hour. So the first thing we're going to do, let's do our equation. I know it says estimate, but in order to do that, I think it's easier to just go ahead with the equation and then we can go back to the estimation. So in order to figure out how much they make individually per hour, I have to divide the price or the money by the hour by the number of people. Okay, so that first part, that's $210 divided by 7 hours. Once I figure that out, I can divide that in half because that's per boy. And I have to take that away from the price of the other store, which is $204, divided by the 6 hours they work. And then once I figure that out, I can divide it by both of the boys. Okay, and that's going to equal, because it does say unknown, that equals, let's use store, S for store, okay? Now I can go ahead and solve. So what I'm going to do is I'm going to use green for Food Lion, and I'm going to use blue for Piggly Wiggly, just to keep them separate, okay? Piggly Wiggly and Food Lion. So let's start with the Food Lion, okay? The Food Lion is 210 an hour. And since I know we have two boys, I'm going to get half of 210. Half of 210, well, half of 200 is 100. Half of 10 is 5, so that would be $105 for per boy. Now, since they work 7 hours at Food Lion, I'm going to divide the $105 by the 7 hours that they work. Okay. So remember, I'm going to use some easy numbers. I know 7 times 10 is 70. 5 minus 0 is 5. 10 minus 7 is 3. That's 35. And I know that's a multiplication fact. 7 times 5 is 35. Take away, nothing left over. So I have 10 plus 5. That's $15 per hour per boy at Food Lion. Now let's do Piggly Wiggly. And I'm going to change my color to blue. So at Piggly Wiggly, they are making $204. Now let's figure out per boy. I'm going to divide that in half. Half of 200 is 100. Half of 4 is 2. So that would make it $102 per hour, or I'm sorry, per boy. Now I'm going to take that and I'm going to divide that by the 6 hours that each of them work. So that's 102 divided by 6. So 6, I know 6 times 10 is 60. That's a good number. 102 minus 60, that is 42. Now think about your multiplication facts. I know 6 times 7 is 42. Take that away. I'm left with nothing left over. Now just add up your quotients. 10 plus 7 is 17. So that's $17 an hour at Piggly Wiggly. So which pays more, Food Lion or Piggly Wiggly? Yep, $17 an hour. That's going to be Piggly Wiggly pays more. So write that in. The Piggly Wiggly pays more per hour. And it pays how much more per hour? Well, now I'm going to do 17 minus the 15. 17 minus 15 equals $2 more per hour. So that's $2 more per hour. Now, when we do our estimate, guys, don't overthink it. Here's what I'm going to do. I've already solved it. For my estimate, I'm going to look, and I got $15 for Piggly Wiggly. And I've got $17 over here. Let's round 17 up to 20. Let's round or keep 15 the same. 20 minus 15 is equal to 5. So my answer should be around $5. And it is. It's around $2, which is really close to 5. And then when it asks, well, does your estimate make sense? I'm going to say yes, because $2 is close to the $5 that I estimated. All right. And that's how you do that problem. Again, I know it looks like a lot of work, but you just have to keep yourself in order. That's why I have some scratch work on this side for one store and scratch work on that side for some more work, okay? All right, let's keep going. So for this problem, I think it would be good to use drawing. It says Mark is cutting off rope to use for a class project. He needs 4 pieces of rope, and each rope needs to be 3 yards long. So again, we are using conversion here. So for this problem, you need to know your inches, yards, and feet. So there are 12 inches in 1 foot, and there are 3 feet in 1 yard. So you need to know your customary conversions. Okay, that's all you need to have memorized for when you get to this problem. So Mark has a 37-foot long piece of rope. How much will he have left over? Or will he have any rope left over? And if so, how much? Now, to answer this problem, I told you I'm going to use a drawing. Okay. So when I go to draw, it says we need 4 pieces of rope and they need to be 3 inches long. So here's what I'm going to do. I'm going to draw 4 pieces of rope. Now I know each rope is going to be 3 yards long. 3, 3, and 3. So 3, 6, 9. That's 12 yards. Well, they're each since they're 3 yards long, there's 3 feet in 1 yard. So if I do 3 times 3, that's 9 feet in every 3 yards. So 9, 9, and 9. So if I do that, I know that 9 feet times the 4 pieces of rope, and I'm going to use an unknown here for my equation, 9 times 4, and let's use R for rope. So 9 times 4 is equal to R, okay? So 9 times 4 is equal to 36. 9, 18, 27, 36. So all 4 pieces, that's 36 feet of rope. Now, do we have enough? Yes, and we will have some left over because we have a 37-foot piece. So yes, there is rope left over. And when I subtract 36 from the 37, that leaves me with 1 foot of rope left over. Don't forget your unit, which for this problem is feet. You got to be careful because your units could be yards or inches depending on the problem. All right, now let's keep going. Number 8, we have some fractions. It says if your textbook weighs half a pound, what would be the weight of 3 history books? Now, this problem is interesting. Remember earlier, I told you that fluid ounces are different than actual ounces. There are 8 fluid ounces for every cup, but when we're talking about weight in pounds, there are 16 ounces for every pound. So I'm going to write that on the side because we should also have that memorized. There are 16 ounces for 1 pound. So let's figure out how many pounds we have. So we have 3 textbooks or 3 1/2 pound textbooks. So 3 times 1/2 is equal to 3 halves. And I'm gonna convert that. And when you convert, guys, you can model or you can just draw it out. For this, I'm gonna model it for you. So I'm going to draw my shapes and then I'm going to draw them as halves because that's my denominator, okay? So split them in half, and then I'm going to shade them in. 1/2, 2 halves, which is a whole, 3 halves, which is a whole, and 1/2. So all 3 textbooks will weigh a whole and a half of a pound. So 1 1/2 pound. The problem says, how many ounces is that? Well, let's try to figure that out. So since we have 16 ounces for every pound, 1 pound of our 1 1/2 is 16 ounces. But then you need to ask yourself, what is half of a pound? Okay, well, half of 16 is 8. So a half is 16 ounces. So 16 ounces plus the 8 ounces is 24 ounces. Okay. So 1 1/2 of a pound is 24 ounces. And when it says explain, one main thing that your teacher is going to look for when you go to explain your answers that you know that 16 ounces is a pound. So what I'm going to do, I need to make sure that I write 16 ounces is equal to a pound, okay? And then after you tell me, since I know 16 ounces is a pound, then you can go ahead and finish off the rest of it by telling us what you did. Um, I know, so 16 ounces is a pound, and also half of a pound is 8 ounces. So 16 plus 8 is equal to 24 ounces. Okay, so that's the main thing that your teacher is going to look for, is that you know that there are 16 ounces in a pound when you find your answer. All right. Then we're gonna keep going, okay? We're getting closer to the end, okay? Now this part is a pattern. Problem 9. When we look for patterns, it's important that you guys look at each sequence or what happens between each problem to in your pattern, and then it has to fit for every sequence. So I'm going from 5 to 10, and you're probably thinking, well, I can just do times 2. Well, can I do 10 times 2 to get 17? No. So let's look at it again. I have rows and columns, and then I have this one circle up here. So I know I've got a 2 by 2. 2 squared is 4, plus one more. Okay, that's a square number plus 1, that's 5. Okay, let's look here. A square number is when you have the same or a number times itself to make another multiple. So here I've got 3 rows of 3 columns. That's 9 plus one more equals 10. Okay, that works so far. Let's look at this one. This next pattern is a 4 by 4 square. 4 times 4 is 16. Plus one more is 17. So our rule here is you square each number, or you get a square number, and then you add 1 to the top. So a square number plus 1 at the top of your shape, okay? So for this next one, since we did 4 square, I'm going to do 5 square. So 5 square, that's 5 rows and 5 columns. 5 times 5 is 25. And then after you do that, please don't forget to fill in. Don't be lazy. Fill in your shapes. All right, 5 times 5 is 25. And then you're going to add one more at the top to give you 26. That's the next problem in your pattern. Now, how do you know how many dots to add to each time? Um, so when you describe this one, I would just say that each number is one. Okay, so or you can say we add a row to each box. Well, a row and a column. Yeah, a row and a column to each box in every sequence. Okay. So that's how you do your pattern. Now, this last problem is the fun one. It's the line plot. When we do line plots, we are going to graph data on a table given by, and we're already given the measurements for it, okay? And then we have some questions that we're going to answer. When you are writing a line plot, we have all the data listed, but you also need to write a title. It needs to make sense. Label or write your numbers and then label the data at the bottom as well, like what those numbers are for, okay? So this problem says that Mr. Jenkins is keeping track of how much juice each student drank. He measured them to the nearest 1/6 of a cup, and these are the results, okay? So the title of this, just because, okay, Mr. Jenkins class, or how about we can say, um, let's just say the juice drank in class, okay? Or in Mr. Jenkins class. Juice drank in Mr. Jenkins class. Now I have these spots at the bottom. These are going to represent each of the 6 of cups of juice that we drank. So when we label this, let's just say um juice drank to the nearest cup. Now let's go ahead and label it. The smallest one here, we have a 0. Then I'm just going to go up by 1/6 each time. Even if I don't have any on that measurement, I still need to have it included on the table. So 1/6, 2/6, 3/6, 4/6, 5/6, and then I have 6/6, but instead of putting 6/6, I'm going to put a whole because 6/6 is 1, and then the next one would be a whole and 1/6. Now that I have my numbers labeled, I can go up to my data and I'm going to cross them off each time I write an X on the line plot. Guys, the X is going to represent each student, and we're crossing them out of the top so we don't use a number more than once because then that can mess up our answers. So I have 1 and 1/6, so I'm going to put an X there. I have 1 5/6, put an X there. 3/6, don't forget to cross them out. 4/6, cross it out. Another 4/6, cross it out. I have 2 zeros. Don't forget to write 2 X's for your zeros. Cross them out. Then I have another 3/6, cross it out. 5/6, cross it out. Another 5/6, cross it out. And then a 2/6, and then don't forget to cross it out. So here's what your line plot should look like. If you need to pause to make sure you have it, you can do that now. So now that I have completed the line plot, that's done. It says how many times did students drink 5/6 cup of juice? Well, there are 3 X's or 3 times that 5/6 has come up. So that's 3. That is what we call the max. No, I'm sorry, that would be the I don't know what you call that. So we've got 3 cups of juice, I forgot. Now it says how much juice is that all together? So we're going to look at 3 groups of 5/6. So I'm going to do 3 times the 5/6. So 3 times 5 is 15. 6. We've got another improper fraction. Again, we can either decompose this, draw a model, or divide. So because I've done several strategies, I'm going to divide on this strategy, okay? I'm going to do 15 divided by 6. So 15 divided by 6. I know 6, the closest I can get is 12. And that's because that's 6 times 2. That's my whole number. 6 times 2 is 12. 15 minus 12 equals 3. So I've got 2 wholes. And this remainder that I have here, I'm going to make that into a fraction by putting it on top of my denominator, which is 6. So I've got 2 wholes and 3/6. Now, if you were to draw it out, which some of you like to draw them out, and I don't think that's a good strategy. You're going to make your shape, and since our denominator is 6, we're going to split them up into 6 pieces. And then I need to go ahead and shade in 15 of them. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now look at our drawing. I have 2 holes shaded in, but then I have half of this circle shaded in. So another way we could write this would be 2 1/2. 2 holes and a half. All right. Now this is our entire study guide, guys. Make sure you do your best, have things written down. Ask your teacher's question if you're not sure about something, and happy testing.